So hello dear students, today I am here to discuss on turbo machines as a part of your basic mechanical engineering. So we need to discuss in detail about the working of some turbo machines like turbines and pumps, where a few classification or few types will be discussed in detail based on your required syllabus. So what actually a turbo machine is? So a turbo machine is actually a device that actually converts or that actually do some energy transfer between a flowing fluid and a rotating element. A rotating element may be commonly called as a rotor, and this actually imparts some change in pressure or momentum to the fluid. In that particular area, in that particular context, your turbo machines can be of two types. It can be a power generating turbo machine, or it can be a power absorbing turbo machine. Power generating means you can utilize the energy of the fluid to rotate a particular rotor. So say for example is our turbine. So in a turbine, what will happen is, as the fluid passes over a turbine rotor, the rotor rotates, and that rotation of the rotor can be coupled to a your generator, and generator can produce the power output or electricity output. That will be a power generating turbo machine. In the other case, your rotating impeller or the rotor will transfer its energy to the fluid so that the fluid can flow to a particular height. So that type of device will be called as a power absorbing turbo machine. Example will be your hydraulic pump that we are normally using in our homes. So, coming to the details of the turbine, turbines are actually the most satisfactory machines producing mechanical power, because you know that there are no, you don't have any reciprocating members, you don't have much wear and tear happening in a turbine. Simply, you will be having a rotating impeller where the fluid comes in contact with the impeller, and the flow of the fluid causes the impeller to rotate. So normally the turbines will have an efficiency around 85 to 90 percentage or more, and you can, based on the fluid that is being flowing over the turbine, you will be having generally three types: hydraulic, steam and gas turbine. For your syllabus we will be having only hydraulic turbines, where the fluid that we need to consider is only water. Now we can have a look into a hydropower plant where we are having a hydraulic turbine. We will actually build dams across the rivers to keep water in a reservoir, where what we are actually doing is we are keeping water at a particular height. So height is a major factor, because height will actually, if as you are having a are having a reservoir, you are keeping water at a particular high head, so total energy of the water will be high, or you can simply say, tell like the potential energy mgh of the water in a reservoir will be more when keeping at a particular height. Say for example we are having a Idiki dam and all other power generation dams across the state. So everywhere you can see that we are keeping a height something above 60 meters or something like that, above 60 meters or like that, where we are utilizing the water, where you can see at the bottom of the dam you will be having a control gate and a penstock, and through the penstock the water from the reservoir is fed to the turbine. So there the water that is kept at a high potential energy will be transferred to the, or flowing across the penstock to the turbine, and the turbine will be rotated due to the flow of that particular water. The turbine can be of any type. It can be a high head, whether you are having a very high head at the inlet, or you are keeping the water at a very high reservoir with a very high dam like in Idiki dam, or you can have better like lower dams like say Periyar Valley and all in our state. So the outflow will be to your irrigation projects and all, and coupled to the turbine you can see a generator and transformer coupled, where the generator actually produce electricity utilizing the rotation from the turbine, and the transformer can actually transform that particular electricity generated for power transmission. So this is actually an outline about a hydropower plant. Coming to the classifications of hydraulic turbines can be classified based on the head and quantity of water flow. Then you can classify based on the specific speed. Then you can classify based on the flow of water across the runner. Also, you can classify based on the incoming energy. Coming to the classification based on the head availability, you can classify based on the net head, that is head available at the inlet of turbine, where the height of the dam is a matter, or the place of location of the dam is a major factor governing this one. So high head turbine means you need to have a net head more than 250 meters, and for medium head it will be a head between 60 to 250 meters, and low head means your head will be much lower than 60 meters. And in each and every case we are having an examples we will be specifying, like Pelton, Francis and Kaplan, where you can see that in Pelton wheel it requires a very high head. That head will be always more than 250 meters. So Pelton wheels generally are employed in dams where the dam will be located at a very high altitude above the sea level, and also the dam will be having a much height from the ground, and your power generation plant will be kept at a lower part somewhere, uh, kilometers away from your dam. Say for example our Idiki dam is having a Pelton wheel. The wheel power generation wheel is actually kept at your Moolamatam area, which is at the lower part of the Idiki, and the dam, you will be knowing that the dam is at a very high altitude above the sea level. Coming to the medium head turbines, Francis turbines are utilized in major cases, and you also can have Kaplan turbines at low head areas. So as your head availability is more in high head turbines like Pelton wheel, you will be definitely having, or you require only lower discharges or lower water flow for producing a much high powers. Coming to the next classification, you are having based on the specific speed, where the term specific speed means it is the rotational speed at which the hydraulic turbine will operate at best efficiency. So best efficiency means whenever you are having high speed, you require only very low specific speed. So that is why low specific speed turbine is a Pelton wheel, and high specific speed turbine will be a Kaplan turbine, where you require much rotational speed to produce same amount of power produced at a Pelton wheel comparatively between say Kaplan and Pelton. Definitely for the medium one, that will be the example will be a Francis turbine. According to the action or the flow direction of water across the runner, you can have a tangential flow as in a Pelton wheel, where the water strikes the rotor in a tangential direction. Also you can have radial flow, where the water can enters and leaves the turbine radially. Then you can have axial flow in a Kaplan, or Kaplan turbine is similar to a propeller in a ship, so you can have axial flow. The water flow will be parallel to the axis of turbine shaft. Then you can have mixed flow, where the water may enter radially and leaves axially. The main classification you need to keep in mind is based on the incoming energy, where you can have impulse turbine and reaction turbine. Impulse turbine we already discussed, like your high head turbines will be impulse turbines. High head means you are having a pretty much head above at the like above your turbine, or much high head total energy is available at the inlet of the turbine. So in those cases your potential energy of the water will be you can completely convert that into kinetic energy, and at high speed your water will be hitting your turbine rotor. So there the force will be an impulse force, where a very large force will be acting over a very short time on the impeller buckets. And in reaction turbines, where you are not having much high heads, you have to utilize both potential energy and kinetic energy for say for your rotor to rotate. And those examples will be your Francis turbine and reaction turbine. So uh, that is actually a basic introduction to your turbines as a whole and turbo machinery. So always keep in mind the definition for turbo machinery, where we are having an interaction between a fluid and a rotor, and you will be definitely changing the fluid momentum and potential energy of your fluid in a turbo machine. You can have two type of turbo machines, like power generating turbo machines like turbines, and you can have power absorbing turbo machines like pumps. So in pumps we discussed more on turbines till now. What actually a pump do is the pump can give or pump can transfer the rotation of the impeller to the fluid so that the fluid can flow. Say you are utilizing a hydraulic pump to pump water from your ground level to the top floor. How it is possible? Because you are feeding into an electric energy, and that electric energy is utilized by a motor will rotate an impeller. The rotation of the impeller will transfer energy to the fluid so that the fluid can flow from a lower level to a higher level. So with that, I am just concluding the introduction part. Now later we can go for discussing each and everything in your each and every device in your turbine and pumps. So thank you for now. um, have a nice day.